In this video, we will be looking at how to solve non-homogeneous linear ordinary differential equations. The general form of a non-homogeneous linear ordinary differential equation with constant coefficients is of the form y double dash plus ay dash plus by equal to r of x, where r of x is not equal to 0. If r of x is equal to 0, it is called a homogeneous differential equation, and you have already studied how to solve such equations. We will be looking at the case where the right hand side, that is the r of x, is not equal to 0. To be a bit more specific, we will be dealing with cases where this coefficients a and b are constants, that is, they are just real numbers. Now, the general solution of such an ordinary differential equation will be of the form yh plus yp. That is, it will have two parts, yh and yp. The sum of these two will be your general solution. Now, what are these yh and yp? yh is the solution of the corresponding homogeneous part, and yp is called a particular integral. Now, first we will look at how to find yh. To find yh, what you have to do is you have to look at the corresponding homogeneous equation. That is, consider the equation with the right hand side equal to 0. You have already studied how to solve such equations. You solve those equations, and suppose c1y1 plus c2y2 is the solution of this given differential equation 2. Then yh is c1y1 plus c2y2. So what is yh? Yh is nothing but the solution of the corresponding homogeneous equation. That is, you just consider the right hand side to be equal to 0, solve that specific equation, you write it as yh. Now we look at the second part, yp. In this video, we will be mainly looking at how to find yp, or the particular integral. The method that we will be looking at here is called the method of undetermined coefficients. This method basically depends upon your r of x. This method is usually used in cases where your r of x is an exponential function. There are a lot of cases. One is it can be an exponential function of the form e raised to ax, maybe e raised to 2x, e raised to 3x, or something like that. Or it can be sine or cos. That is, r of x can be, say for example, sine 2x or cos 3x, anything like that. It can be a polynomial also. It can be x raised to 4 or x square plus x, etc. Or it can be combinations of these. For example, e raised to 2x into sine x. We will look at how to find yp in such cases. So we will be considering each different case specifically. The first case we will be considering when your right hand side is an exponential function. So consider the ordinary differential equation y double dash plus a into y dash plus by equal to r of x. The first case is, suppose if your r of x is k into e raised to alpha x. That is, suppose it is something like, say, 2 e raised to 5x. Then how to find yp? Now, in such cases, the choice of yp, that is, we will first be looking at a trial solution. So the choice of yp will be c into e raised to alpha x, where c is an arbitrary constant. And then we will find yp dash and yp double dash, and we will substitute those things in this given equation. We will equate the left hand side and the right hand side to find capital C. And then we will write the general solution as yc plus yh plus yp. Now let's look at a problem. Okay, the problem here is y double dash plus 5 into y dash plus 6y equal to 2 e raised to minus x. Now, as I told you, the solution of such an equation has two parts. One is yh and one is yp. How to find yh is just take this right hand side to be equal to 0. and solve it. Suppose the right hand side is equal to 0, then how do you solve it? You have to first write the characteristic equation. That is, in place of y you write down 1, in place of y dash you write down m, in place of y double dash you write down m square. Then you will get the characteristic equation as m square plus 5m plus 6 is equal to 0. Now what are the roots of this characteristic equation? It is minus 2 and minus 3. So the general solution will be c1 e raised to minus 2x plus c2 e raised to minus 3x. So now you have found YH. Your YH is c1 e raised to minus 2x plus c2 e raised to minus 3x. You already know how to solve the homogeneous part, so I am not elaborating anymore. Now we will look at how to find YP. So here you look at what your right hand side is. R of x is equal to e raised to minus x. So your choice of yp should be c e raised to minus x. That is any constant multiple of e raised to minus x. Next thing is you find yp dash and yp double dash. You find its two derivatives. Then you have to substitute those values, that is yp dash and yp double dash in the given equation, and then equate both sides to left hand side and right hand side. So equate both sides of the equation to find your capital C. So that is what we are going to do. So your yp dash is minus c e raised to minus x, yp double dash is c e raised to minus x, given yp is c e raised to minus x. Now substitute those in the given equation. You will get it as, when I substitute, we are getting it like this: c e raised to minus x minus 5 into c e raised to minus x plus 6 c e raised to minus x equal to 2 e raised to minus x. The actual equation was y double dash minus 5 into y dash plus 6y equal to 2 e raised to minus x. So we have substituted those corresponding values there. Now equating both sides of the equation, this left hand side turns out to be 2c e raised to minus x and right hand side turns out to be 2 e raised to minus x. So c, the value is 1. So what is your yp? Yp is c e raised to minus x. So the specific yp, that the answer we get here is yp equal to e raised to minus x. So as I told you earlier, the general solution is yh plus yp. Yh we had already found it. It was c1 e raised to minus 2x plus c2 e raised to minus 3x. Yp we found it now. It is e raised to minus x. So y is yh plus yp. This is how you have to find the solution. Now we will move on to the next case. That is, suppose